All right, guys, second video. So let's see, we're working with quadratics, and we are certainly going to work with some perfect square trinomials and review solving quadratics by completing the square. It's a really important skill to be able to do. That'll come into play later on in the year. Okay, so we have these formulas. For those of you that had me for geometry, you've seen these formulas. And we know if we square a binomial, that's the same as multiplying a binomial by itself. And clearly you could use the FOIL method, okay, on both of these to get this. But we don't want to do that. We want to skip over, okay, that FOIL method, and we want to apply a formula. So it's a pattern. Okay, and the only difference is the sign of the binomial. Okay, if we square a binomial, we always end up with what's called a perfect square trinomial, which are really important. And notice that whether we square a plus b or a minus b, you get the same thing. The only difference is the sign of the middle term, that linear term. So notice in both of them, we take the first term and square it, so we get a squared to start off with. Okay, then we go 2 times the first times the second. So it'd be 2 times a times b, which is 2ab right here. The only difference is the middle term takes a sign of the binomial. So if it's a plus b, you get plus 2ab. And if it's a minus b, you get minus 2ab. And then the third term is always positive, okay, and it's just the second term squared, so b squared. Okay, so notice that these two guys are almost identical. The only difference is the sign of the middle term, the linear term. That always takes the sign of the binomial. Okay, so having the ability to use these formulas is really important. Okay, and so let's practice on that first. Okay, so right here, notice I'm squaring a binomial. Okay, so I get the first term is 3x, the second term is 4. So I take the first term and square it. We got to make sure we square everything. Okay, bring the operational sign over. Okay, then the middle term is always 2 times the first, 3x, times the second, 4. And then the third term of the trinomial, and it's a perfect square trinomial, is always positive, and we take the second term and square it. And then we just simplify. So when you square 3x, you get 9x squared. Bring the plus over. 2 times 3x times 4, well, that would be 2 times 3 is 6, times 4 is 24 with an x, so that would be 24x. Always plus, 4 squared is 16. And this guy is a perfect square trinomial. Perfect squares are always trinomials in algebra. Okay, you would never get like a perfect square binomial. Okay, perfect squares are always trinomials. Okay, so let's see right here. I take the first term and I square it. Okay, then it's minus 2 times the first times the second, so 2 times x times 7, always plus second term squared. And the result, once again, will be another perfect square trinomial. So I get x squared minus 2 times x times 7, that's 14x, plus 7 squared is 49. Okay, same thing here. Take the first term and square it. So square the 3x. Bring the minus sign over. And it's always 2 times the first term, 3x, times the second term, 10, always plus second term squared. And then we simplify. When you square 3x, you get 9x squared minus 2 times 3 times 10, that would be 60 with an x on it. And then plus 10 squared is 100. Again, another perfect square trinomial. All right, now you could have a binomial with more than one variable in it. We don't see them a whole bunch, but they happen. But it's the same thing. Okay, take the first term and square it, and square all of it. So square the 4x, bring over the sign. Middle term is always 2 times the first term, which is 4x, times the second term, which is 3y. Then it's always plus second term squared, and make sure you square all of it. And then we simplify. So when you square 4x, we get 16x squared. That's a plus. So let's see, 2 times 4 times 3. That'd be 2 times 4 is 8, times 3 is 24. And notice you have an x and a y. Plus, when you square 3y, you get 9y squared. And another perfect square trinomial. Okay, same thing here. Let's see, we take the first term and square it. So you take the 11 and square it, bring the sign over, minus. Middle term is always 2 times the first term, which is 11, times the second term, which is a squared b. Always plus second term squared, and make sure you square all of it. Okay, so 11 squared is 121. Bring the minus over. So let's see, 2 times 11, 22. And notice that would be a squared b. Plus, when I square a squared b, I would get a to the 4th b squared. To the 4th b squared. And another perfect square trinomial. Okay, last one. Take the first term and square it. You got to square all of it, so 4a cubed, square it. Bring over the operational sign, the plus. Middle term is always 2 times the first, which is 4a cubed, times the second, which is 7b to the 4th. Third term is always plus. Square the second term, 7b to the 4th. You got to square all of it. Okay, well, let's see. When I square 4a cubed, I get 16a to the 6th plus, let's see, 2 times 4 times 7. 2 times 4 is 8. 8 times 7 is 56. And then I'd have an a cubed and a b to the 4th plus, when I square 7b to the 4th, I'm going to get 49b to the 8th. And notice how I didn't have to use any FOIL method at all. And once again, these formulas, and I know if you had me last year for geometry, we hammered away on those guys in the second semester. Okay, really important that you get used to using these formulas. Okay, all right. So using the formulas, all these problems, we're taking the square of a binomial and expanding it. Okay, now we can also use the formulas to go backwards and factor. Okay, and part of the factoring, will show up when we review solving quadratics by completing the square. Okay, and part of that is if you're given a quadratic term and a linear term all the way down, okay, how do you come up with the constant term that creates a perfect square trinomial? Okay, this is all, you guys all learned how to do this in Algebra 1. Okay, I'm sure a lot of you have forgotten about it, but it's really easy to do. Okay, so if I'm given the quadratic term and the linear term, and I want to find, well, what does that constant term need to be to form a perfect square trinomial? Okay, we always take the linear coefficient, we divide by 2, and then we square that. Okay, so I would take the 8, I would divide by 2, and then I'd square that. And this forms a perfect square trinomial. Okay, so you would get x squared plus 8x plus, notice this would be 4 squared, like this, which is the same as x squared plus 8x, okay, plus 16. Okay, now when you factor that, that's a perfect square trinomial. So it factors into the square of a binomial. Okay, here we're using these formulas, and we're starting here and going back to this, back to factored form. Okay, so you say, okay, well, what goes in here? Take the sign of the middle term, the linear term, and then we take the square root of the first term, square root of x squared is x, and take the square root of the last term, the square root of 16 is 4. And then you can mentally check it. Notice if I take this and expand it, square the first term, I get x squared, bring the plus over. The middle term has to be 2 times the first times the second, so I'd get 2 times x times 4, which is 8x, and then always plus, okay? Second term squared, 4 squared is 16, so it works. Okay, so let's see, we go here. Same process. Take the linear coefficient, divide by 2, and square that. Okay, so I'm going to get x squared plus the 12x plus 12 divided by 2 is 6, so that'd be 6 squared. Okay, so that would give us x squared plus 12x plus 36, and that's a perfect square trinomial. So you say, okay, let's factor that. Well, it factors into the square of a binomial. Bring the sign of the linear term, the middle term, over, plus. Then you take the square root of the first term, so the square root of x squared is x, and you take the square root of the last term, the square root of 36 is 6. And then you can mentally check it, okay, using your formula to expand this guy. So the first term squared, x squared. Sign of the middle term is the operational sign of the binomial. Then it'd be 2 times the first times the second, so you get 2 times x times 6, that's 12x, plus second term squared, 6 squared is 36, so we're good. Okay, so let's see, right here. Okay, we're gonna take the linear coefficient, divide by 2, and then square that. Okay, so that would be x squared minus 10x plus 10 divided by 2 is 5, so that'd be 5 squared. Okay, so we're going to get x squared minus 10x plus 25. That's a perfect square trinomial. And then we factor it into the square of a binomial. Okay, so the sign here is the sign of the middle term, so that'd be minus. Square root of x squared is x. Square root of 25 is 5. And you got it. And again, we could expand this and make sure we get x squared minus 10x plus 25. So first term squared is x squared. Bring the sign over. Middle term will be 2 times x times 5. That's 10x. Plus second term squared. 5 squared is 25. We're good. Same thing here. Take the coefficient of the linear term, divide by 2, and square that. So I'd get x squared minus 16x plus 16 divided by 2 is 8, so that'd be 8 squared, which would give us x squared minus 16x plus 64. Perfect square trinomial. And then we can factor that. Bring the sign of the linear term over the middle term, that's minus. Square root of the quadratic term, the first term, square root of x squared is x. Square root of the constant term, that last term, square root of 64 is 8. And we're done. That's our factored form of the perfect square trinomial. Okay? Now these get a little bit tougher because notice that up here, all 4 of these, notice that the linear coefficient is even, so when you divide by 2, it divides evenly. Here, the linear term, or the linear term's coefficient is odd, so when you divide by 2, it doesn't divide evenly, so we leave everything in fraction form. But it's the same process. Take the linear coefficient, divide by 2, and square that. Okay? So we would get x squared plus 9x plus 81 over 4. Now remember, when you square a fraction, you just square the numerator and denominator. So 9 squared is 81, 2 squared is 4. That's where I got the 81 fourths. Okay? And then we factor that, okay, into the square of a binomial. Same process. Take the sign of the linear term, that middle term. Okay, square root of the first term, square root of x squared is x. Square root of 81 fourths. Well, the square root of 81 fourths is right here, 9 halves. Okay, remember, you take square root of a fraction, apply your quotient rule. So the square root of 81 is 9, square root of 4 is 2. And we got what we need. Okay, last one. Same process. Take the coefficient of the linear term, divide by 2, and square that. And obviously 5 is not divisible by 2, so it stays in fraction form. So we get x squared minus 5x plus square the numerator and denominator, so we get 25 fourths. And that's a perfect square trinomial, just like the guy above us. So we factor that into the square of a binomial, bring the sign over, so that's minus. The square root of the first term, square root of x squared is x. Square root of the third term. Well, the square root of 25 fourths is right here, 5 halves. And once again, remember, when you take square root of a fraction, you apply your quotient rule. Square root of the numerator is 5, square root of the denominator is 2. And we are done there.